Hey, Mr. Bell here. Week 2, distance learning, solving radian trig equations, level 1. Let's get right to it. Okay, so here's some of the steps or success criteria that you can refer back to when solving these. We first want to isolate the trig function. Okay, now remember, these are the problems that you're going to see second half of the week, radian trig equations right here. Okay. All right, so solving these, we're going to isolate the trig function. Step 2, consider possible quadrants based on the sign, positive or negative of the function. Or, who knows, it could be quadrantal as well. Multiples of 90 or multiples of pi over 2. So if that's the case, we'll use the unit circle to kind of investigate the possibilities, okay? And these kind of work hand in hand. We're going to want to draw some sketches to kind of work backwards to justify our solutions, okay? So let's start with this one here. Let's take a look at the directions. It says solve the trig equation for the values 0 to 2 pi. Okay, so what we want to do first is isolate this. This one's pretty straightforward. In terms of the isolation, we're just going to go ahead and add 1 to both sides. Okay, so we have cosine of x equals 1. All right, now remember, getting zeros and ones quite often comes from the multiples of 90 degrees. Now, tangent's an exception. If it was tangent over here, we could get 1 from the 45, 45, 90. But that's not going to happen with the triangles. Okay, so if you tried that route, fine, you'd run into a dead end. All right, so let's go ahead and take a look at the unit circle approach here and consider these coordinates. Remember, we're considering a radius of 1. So if that's the case, this must be 1, 0. Here, I'm going up nowhere, up 1 on the y-axis, nowhere on the x. So we have 0, 1. You guys are familiar with coming up with these. Get these coordinates in front of you, okay? All right, so we just kind of figure out, using the definition, we know working backwards, using the definition of cosine. Cosine of an angle is always defined as the x value over r. Okay, if that extra x is throwing you off, just throw in theta then. Cosine of an angle, right? All right, so which of these spots would produce a value of 1? Well, I'm going to need an x value of 1 and an r value of 1, right? These x values of 0 clearly won't work, and negative 1 won't work either because I'm looking for a positive 1. So which of these coordinates has the x value of positive 1? There it is. So simply put, our answer is going to be theta equals 0. You might wonder, should I rotate around and consider 2 pi? Well, oops, I put an equal sign there, but if you look at the directions, it doesn't include 2 pi, right? We're not supposed to include that, so let me get rid of that in my inequality. So 0 is the only solution. That's it, okay? All right, let's move on to another example. Okay. So step 1, we need to isolate this again, right? Now I have a coefficient of square root of 3. Remember, when it's out there by itself, it means to multiply. So let's go ahead and divide by square root of 3, so we get 1, and balance the equation. Okay, so we get cosecant theta, or x, equals negative 2 over square root of 3. Okay, now it's easier to get this in terms of sine, cosine, and tangent. I mean, you don't have to, but I definitely prefer it and recommend it. So recall that cosecant theta, or x, is equal to 1 over sine x. This is a relationship, a reciprocal relationship that we've been using quite a bit in the third marking period. All right, so watch what happens if I substitute this with this. So this becomes 1 over sine x. Okay, we're still on step 1 here, right? Isolating the trig function. Okay, so to isolate this trig function, we need to get this out of fraction form. So I think you should cross multiply to get it out of fraction form. Let's put this negative 2 sine x on the left, and then 1 times square root of 3 is square root of 3. Okay, cross multiply, set equal. Now divide by negative 2. And clean it up, and this is what we get, right? Sine of x equals negative square root of 3 over 2. Okay, let me show you a little shortcut to this. This is kind of the math reasoning behind it. But what you can do is just take the reciprocal of both sides if you want. Okay, once I isolate it, this part's still key, but from here, we take the reciprocal of each side. It's a little shortcut. Okay, here's what I mean by that. What's the reciprocal of cosecant? Okay, sine x, what's the reciprocal of this? Flip it over. Okay, so then you can skip the cross multiplying and substitution that I did. See, we're at the same spot. All right, so reciprocal of each side is what you could do. So if you had like a secant right there, you'd say cosine. If you had a cotangent x, then you'd say tangent on the left. And just flip over the right side, okay? All right, now from here, this should look familiar if you did your problems earlier in the week. Okay, so we just continue and solve this the rest of the way. Okay, so step 2, we want to consider the quadrants where sine is negative. Okay, remember, a smart trig class. Sine is not positive in the first quadrant. Sine is positive here. I'm sorry, sine is positive in the first quadrant. I was thinking forward to the negative. Okay, so it can't be in quadrants 1 or 2 because that's where sine's positive, just to clear that up. Sine is negative in quadrants 3 and 4, okay? So there's our possibilities right now. So let's kind of draw bigger reference angles now, bigger sketches, so you can see at home and you can follow along a little better. So we want to drop an angle somewhere in the 3rd quadrant. Let's go ahead in the same sketch, drop an angle over here into the 4th quadrant, but one at a time. Let's start here. Let's create a reference triangle with the x-axis. Remember, we always make our reference triangles with our x-axis. And let's work backwards. Sine is y over r, or opposite over hypotenuse. So opposite this reference angle, I'm going to replace square root of 3. Okay, hypotenuse 2. This is looking like our 30, 60, 90 relationship. It is. If you weren't sure and needed to use Pythagorean theorem off to the side, you could. Okay, so remember, to get to this point, we got negative x, negative y. All right, this is working, right? Sine of that reference angle is negative square root of 3 over 2. So the angle opposite square root of 3 is always going to be 60 degrees. So that must mean that this angle now is going to be 180 plus 60 to get to that spot. And we'll add your reference angle. So we get 240 degrees. All right, now it looks like the directions are asking us to put this in radian. Yep, radian trig equations. So let's go ahead and take this now and multiply it by pi over 180 and then reduce. Okay, so this reduces to 4/3. So the answer in this quadrant is 4 pi over 3. Okay, all right, be a little quicker in the 4th quadrant. All right, because we know now that we should put negative square root of 3 over here, opposite this reference angle. 2 hypotenuse, this is positive 1, so we get 60 degrees. Okay, so what's this angle? Remember, just 60 degrees short of 360, so that's probably an easier way to do the math. Or you could do 270 plus 30. 300 is what we get on this one. So 300 degrees, multiplying that by pi over 180, reduce this fraction, and we end up with 5 pi over 3. Okay, so there's our solutions that we'll go punch in. I think I'll model this one more time in case you forgot how to punch in 2 solutions. This is where you hit this positive sign right here. All right, that adds another answer blank, and you can take it away if needed by doing that, okay? So you're going to put 4 pi over 3 in here. Remember, the pi button is... Oh, come on, let me put it in there. Oh, yeah, click this button. So we'd say 4 pi over 3. Like that. Okay. Remember, somebody else brought up a square root issue. If I want to do square root of 3 over 2, I know it's not the answer. I'm just demonstrating here. If I want to do square root of 3 over just 2 and get it out of the fraction, you got to hit this forward button. So hit forward and divide by 2. That's how I can do something like that. Okay. If you still want it all under the fraction, then I wouldn't need to do that. Okay. So anyways, I just wanted to show you how to punch that in. Okay, so the next one will be 5 pi over 3. Submit it, and you'll get the right answer. Okay, moving on. One more example I want to show you. is a square root trig function here. Here's how we're going to isolate this one. Okay, and here it is looking, or how it's presented on delta math. 2 cosine squared of x minus 1 equals 0. Let's add one first. Divide by 2. Okay, now I'm not quite isolated. One last step that we need to do is to take the square root. Okay, so I'm going to take the square root of cosine squared x, which is going to just give me a single cosine x. And then I need to do the same thing to this side. So we're going to say plus or minus the square root of 1/2. Okay, don't forget the plus or minus. All right, when taking square roots of fractions, we can consider the top and bottom separately. Kind of break it apart like this. Square root of 1 is 1. All right, and then we need to rationalize this. Okay. All right, and it is positive or negative, so let me clean up what we have now. Cosine of x equals plus or minus square root of 2 over 2. Okay, and now this goes back to our skills earlier in the week and even the last problem, this scenario. Okay, but the only issue is now I've got plus or minus. What does that mean? Well, actually, cosine is positive in 2 quadrants and it's negative in 2 quadrants. Let me break it up here for you just to make sure it's really clear. So we have cosine of x equals square root of 2 over 2, and cosine of x is negative square root of 2 over 2. Okay? Where's cosine positive? Cosine's positive, where all are positive. Our trig class, here and here. Where's cosine negative? The other two. So this one happens over here in quadrants 2 and 3. Okay? So it seems like a lot, but once we get the reference angle, it's going to go quick. Okay? This is what I mean by this. Here we go. I'm going to slow down the first quadrant, then I'm going to go quicker on the others. All right, so we should recall square root of 2 comes from our 1, 1 square root of 2 triangle, our 45, 45, 90. And it's confirmed here. Take the cosine of this. What do you get? Adjacent over hypotenuse, x over r, 1 over square root of 2. Okay, but it's rationalized, and we kind of did that up here already, right? 1 over square root of 2 is square root of 2 over 2. So these are equal. Okay, so I just came up with an answer right here in the first quadrant. Theta is 45 degrees, which is also pi over 4 in radians. Okay, now that we know the reference angle, this is going to go quick. All right, where else is it positive? Fourth quadrant, so it's rotating all the way around here into the fourth quadrant, and it has a 45-degree reference angle. Okay, I don't need to justify the sides again. I already did that in the first quadrant. What is that angle? Is all we need. It's 315 degrees. Okay, so these two answers, which is what, 7 pi over 4 in radians. These two answers satisfy this first one. Okay, but what about when it's negative? Easy enough. 45-degree reference angle. So what is this? It must be 135, right? Because 135 plus 45 is 180. So this is a 135-degree angle in quadrant 2. What about over here? What creates this 45-degree reference angle? Well, we need to do 180 plus 45. Okay, so this is going to be 225. There you go. There's all the angles. I have them in degrees, some of them in radians. So convert those to radians and you get the answers. So this one needs 4 answers. And remember, you just keep hitting the plus signs here to have enough space to put them in. Okay? It's about as tough as they get, about as long as they get. Sometimes you might have 4 answers. Or on the first page, we had 1, right? Okay, so take your time. That's why I think I only assigned 8 of these problems. I gave you 2 days to do them, all week really, but Thursday and Friday was kind of the goal to be working on this final set of problems. Okay? All right, good luck to you. Like always, shoot me an email. If you have any questions, I'd love to help you. Good luck and stay safe and go Cards.